Hello everyone, I'm Dr. Emilia Bertolo. I'm a principal lecturer in chemistry at Canterbury Christchurch University. This is the first of a series of videos dedicated to kinetics and equilibrium. We're going to be looking at how fast a chemical reaction goes and what we mean by reaction rate, which is how fast a reaction goes, what we mean by activation energy and why we should care about activation energy, and also some of the factors that influence the speed of a chemical reaction, the reaction rate. We're also going to be looking at some simple calculations involving kinetics concepts. Finally, there will be a part of these videos dedicated to chemical equilibrium. What does it mean that when a reaction reaches equilibrium? What are the conditions that would alter the equilibrium? And how we can apply something called the Chatelier's principle to make a reaction which is in equilibrium leave the equilibrium condition, at least for a short period of time. As usual, these are not videos aimed at students doing a chemistry degree, but at those of you that are doing chemistry as part of your other degree. If you have any questions, just drop me an email. When I think of thermodynamics and kinetics, I like to think of the question that those two branches of chemistry answer. I'm going to write here an equation. It's quite a typical one, the reaction of hydrogen and oxygen to produce water. And I'm going to balance it. And then when I look at that equation, the first thing I might ask myself when I look at any chemical equation is, will this reaction actually happen? And thermodynamics answer that. And we have a particular thermodynamic variable, and it's called Gibbs free energy, delta G, that tells us, yes, it will tell us if a reaction will happen or not, spontaneously. And we know that delta G, when it's a negative number, that means that the reaction is spontaneous. And when delta G is a positive number, we know the reaction will not be spontaneous. If we wanted to make it happen, we will have to do something about it. Another question that we can ask ourselves when we are looking at a chemical reaction is, will this reaction absorb heat? So will I have to heat it up, or will it release heat? And we have another thermodynamic variable to help us answer that question, and is delta H, enthalpy. And we have that the enthalpy of a reaction, which is negative, we call that reaction exothermic. And yes, that reaction will release heat. And if delta G is endothermic, the changing enthalpy is positive, and that means the reaction will absorb heat. So this is the realm of thermodynamics. Thermodynamics tells us if a reaction is going to happen or not spontaneously, and if it happens spontaneously, or when it happens, will it release or absorb heat? What thermodynamics cannot tell us is how fast will it happen. For example, the reaction you have there with hydrogen and oxygen to produce water is both spontaneous and exothermic. So it will release heat when it happens, and it will be spontaneous when it happens. But unless we do something about it, in this case use a catalyst, etc., we can go into that, it will just happen very slowly. You can mix the hydrogen and the oxygen together and nothing will happen, because although it's thermodynamically favorable, so the thermodynamic variables, both delta G and delta H, work in favor of that reaction being spontaneous, is kinetically very slow. So how fast will it happen is not the question for how will it happen. Thermodynamics cannot help us answer that question. Kinetics will tell us how fast a reaction will happen and how can we make it go faster. And this is what we're going to be discussing in the next few videos. And something else I need to consider is what happens if a reaction gets stuck. And by that I mean, typically one has a certain number of reagents, let's say A and B, and makes certain products in certain quantities, let's say products C and D, and that's all well and good. So A and B react to give you C and D. What happens if at some point in the reaction actually C and D start reacting back to give you A and B. So A and B are reacting to give you the products, and the products C and D are reacting between themselves to give you the reagents A and B. That's what I mean when I say a reaction gets stuck. In chemistry, when a reaction gets stuck, we say that it has reached equilibrium. And it's a dynamic equilibrium. We'll talk more about that in a future video. It's not that the reaction is not reacting. No, it's happening all the time. It's that the speed, the reaction rate of the reaction going forward is the same as the reaction going backwards. So you kind of see it frozen in time, when in reality it's just reacting all the time. It's just that you make the products and the products react back to give you the reagents. And how can we deal with that? Do we have to accept that, okay, a reaction has reached equilibrium, that's it? Well, actually, no. There are quite a few things that we can do to get the reaction out of equilibrium. It will go back to the equilibrium, but in the meantime, we might be able to get more products out of it. And that's what I mean when I say, okay, what can we do if it gets stuck? And that is the realm of both thermodynamics and kinetics at the same time. So that's when both of them merge together. So what is kinetics, chemical kinetics? Well, it's the study of the reactions as a function of time. We study how fast a reaction happens and how to make it go faster. It studies how chemicals react to form products. Actually, what is the mechanism? The bonds are broken, bonds are formed. That's part of what kinetics studies. It also talks to us about the rate of reaction, how fast a reaction will happen, how long it will take for the reaction to reach completion. So all the reagents have reacted to give the products. It also studies the effect of catalysts and biological catalysts, which are enzymes, which are simply substances that we use to make reactions go faster, to increase the reaction rate. And we will talk about them in a future video. And finally, chemical kinetics also talks about how to control a reaction. And that's when I was saying there's a bridge between kinetics and thermodynamics. When a reaction reaches equilibrium, when it has reached a sort of standstill and the reaction rate going forward and backwards are the same, and no more product is formed because immediately it's destroyed to make the reagents, what can you do about it? And we call that Le Chatelier principle.